Thank you. Hello, everyone. So I'm Mike, and I'm here today to talk about imperative development. So I spent a lot of time writing native modules and extending React Native. And with languages that are sort of less fun than JavaScript, if you ask people on any meetup, like Objective-C. And those languages are imperative. And from the JS community, I've learned that imperative is something bad, something that I should avoid. And the code that I should be writing should be functional, declarative, and pure. It's not really that true when we think in terms of React Native specifics. And so the purpose of this talk is to show you a few use cases that I had, some examples, and maybe demystify this fact that imperative is bad because it might be actually a thing that you eventually going to use and like. So I work at ColdStack, which is a company that I co-founded, and our mission is to help developers and companies to run their apps on all the platforms. And so it just happens that right now we are using React Native, and since we are open source enthusiasts, we are trying to contribute as much as possible to the framework itself, and by going to conferences like this. So if you or your company is in need of some React Native help, please reach out. We'll be more than happy to talk during this conference. So before we start, let's do a quick background check. Please raise your hand if you have ever used React. All right, I'm just testing if you are gonna raise your hand eventually anyway. So the real question is, how many of you know the difference between imperative development and declarative? All right, that's quite a few. So let's do a quick introduction anyway, so that it's easier to follow the slides. Long story short, imperative programming focuses on how the change is going to happen, right? And so you have this container that you want to style. So what you're going to do is you're going to basically set every style yourself line by line. In this case, background, width, and height. So you give it a set of commands, and you expect the end result in return. With declarative approach, on the other hand, you want your container, you describe how you want your container to look like, and you don't think of how it's going to be painted on screen. In our case, that could be React, for instance, where we describe our where we describe our hierarchy in render method, and we expect the framework to take care of that. So the difference between these two is that instead of focusing on low-level implementation details, like whether this property is supported, whether this is going to be styled in that way or the other, we focus on what we want to get. So we shift the responsibility from us over to the framework or library. We trust the library that the library will do its job well. And that gives you the performant code and puts the focus on the application development itself. So back to the title. From Urban Dictionary, the new black is something cool, a new trend to follow. And it's coming from the fashion industry because black is always in fashion. So if something is the new black, it's naturally going to be the cool thing. But imperative programming is not a new thing, right? It used to be around for a while. The hardware implementation of almost all computers are imperative. All hardware is designed to work that way because it sort of executes the machine code, which is imperative. And from the low-level perspective, the state of your program is just memory, and statements that you write are the instructions that imperatively tell the computer or the processing unit what to do as a response to what you want. And if, the higher we go, the more abstractions are built on top, like statements, if statements, and stuff like that. So if imperative programming is not a new thing, what is the title of my talk going to be about, right? So let's take a closer look at one trend that I've observed over the past few years within our community. And you will hopefully have an answer once we are done with this. JavaScript ecosystem, compared to the others, it's still relatively young, if we think of React and React Native and the libraries that we have. And so we don't settle on existing solutions. We constantly keep innovating, right? Every once in a while, there is a new framework or a new library that is about to change something. Like we used to have Redux. Now people are discussing whether it's still the thing to go with. context was bad, now it's not that bad, and stuff like that. So it's changing all the time as our use cases change. And so with our community hanging out on mediums like Twitter, that's the place where we naturally share our findings, right? When we find out something really cool, we post it on Twitter, like, oh my God, this is a cool library that I did, please check it out. And that's what everyone does. Like, we check it out, we install it, we star it, and then we fill in bugs, and that's the end of life cycle. And then the other developers on board the framework, they start following us, and they see those messages, and they treat them as best practices, right? So to give you a better idea, let's take a look at an example. So when starting a React app, the problem most of the people are having right now is, what is the state management solution going to be, right? We are like, oh, should I use Redux? Should I use MobX? How many of you have account on React Native community group on Facebook? Are on that group? Yeah, not that many, which is surprising. You should probably join this group if you want to get first-hand announcements as far as the library. But if you check this group, many people are asking, OK, what are the technologies that I should use? What are the frameworks that I should use? And so setState, which is built-in mechanism, right, to the React, like no one thinks about it. It is sort of considered harmful, right? There is even ESLint rule that is, making setState like an error if you use it. So you might be wondering how something such fundamental as state to React can be an anti-pattern. Like, is the whole framework bad, speaking in terms of those people? So the thing is, developer that is advertising his solution on Twitter, Medium, or any other place, he has some project-specific context in mind. Like when I'm going to be telling you that, like today, those are the things that work for me, they might not work for you because I was doing some very specific things at job. And those circumstances are really important. The problem is, on Twitter, the context fades away, especially given the limit of characters. It's like when I write setState is an anti-pattern and I use some nasty clickbait strategies, this is going to be very popular and no one will be talking about the real thing that was at the end of my article, for instance. So how many of you are using setState or state? All right. So that's a lot of people. And so Dan Abramov said recently, which was a year ago, time flies, or actually 2, but it's OK. When people say setState is an anti-pattern, they mean a 500-line components with a complex setState soup scattered across event handlers, right? So how many of you would use state again after reading this? OK, still few people, but less. So that means, by putting the context necessary, you wouldn't probably use state in such a big component, right? All of you that are using state, we are probably talking of small components, like maybe holding state of a button or a form, right? But not doing state for like a whole app, 2,000 lines, one file, right? Because this is what setState is considered an anti-pattern. This is where it shouldn't be used. So that is the context necessary for this statement. So there was a similar trend in the past. Unfortunately, I couldn't find the original author, so I just put myself. That basically said that imperative code is an anti-pattern. When I was working back in the day on Eshte, which is a great library or a fully-fledged software development kit by my friend, imperative code was like considered an anti-pattern. It was very popular. And in that library, we used to have a lot of issues that, oh, this is imperative, this is not pure, please change it, and stuff like that. And so if you're like me, you agree with this statement, right? Because React brought declarative approach. It sort of took away DOM APIs and all that stuff from us and gave us a nice API to build apps. So essentially, I would say this is right. This is correct. And before I started doing React Native, I was doing iOS development. And so my iOS code was all the way down imperative. Like, it was such a mess that I couldn't even handle it myself after a while, especially the transitions and stuff like that. It was beautiful, but it was really messy. So the purpose of this talk is to show you that in context of React, imperative is not a bad thing, but it's actually something we should be using because it powers a lot of React and React Native abstractions, and is what can take your React Native development to the next level. In fact, we already talked about it. Native platforms are imperative by their design, right? So React and React Native have to ship with those abstractions to handle it. Just like on the web, React is wrapping DOM APIs for us using virtual DOM and some clever algorithms to make it performant. Same thing happens on mobile when React Native is using Bridge to basically render our render tree to Objective-C and to Java controls that are rendered on iOS and Android, right? And so it makes it very easy for a regular developer like me that doesn't know Android to write Android app. Like the first day that I sort of started doing React Native, I felt like senior development because after struggling with iOS for like a month, I was able to do the same in like a week on both platforms, and I was like, Jesus Christ, like that's the end of my career now. And so all thanks to abstractions that are there, all thanks to modules like animated, React Native gesture handler that wrap nasty APIs and expose a very nice interface for you to use. And over the course of past few years doing React Native, I've discovered this contract, this relation between imperative and declarative that is within React and React Native, a beautiful abstraction that can really help you write really interesting libraries. So imperative code is everywhere, and there is no reason to run away from it. All the declarative wouldn't be possible if there wasn't imperative layer below it. So by learning how to use it, you open the doors to write performant apps and APIs. And in this talk, I want to show you a real-life example that uses imperative code to achieve something that is not supported by React Native. I mean, it may sound crazy, but it's not really that crazy. And demonstrate a universal and flexible sort of approach to writing such abstractions in the future. So React Native ships with a lot of great APIs by default. And if you are using Expo, you even get more of them. But despite its ecosystem getting more and more stable and future-reach, there is still that need for native modules and native code when you are shipping something. You may need to wrap a proprietary API, or maybe some module that is not currently supported well. And so it's just good to have this native hatch and be familiar with how the native development works, because that's the way to ensure the long-term stability of your app. And what I also like about this, about writing native code, is that it broadens your horizons. Back in the day, I was like wondering every month, because I've read somewhere in an article that every developer should learn at least one language per year in order to stay up to date, something like this. I'm not really sure if that was proved or not. I just read it. It sticks to my head for a while. And so for some reason, I just couldn't make it. Like, I didn't have enough time. And when I started doing React Native, I got really excited because I was sort of forced to write 3 languages at a time. So that is really great because it helps you to become a better developer too. So you probably already guessed that from the intro to native modules, I was challenged to write one that you can see on the screen. We've been talking about this app quite a few times already, every time from a slightly different perspective. So if you will be interested into hearing more about that, please let me know. It's a music app, and on the screen you can see a component that renders full-screen SVG with nodes. And each node on the screen has its corresponding timestamp, so that I know that, for instance, the one that is already red should be highlighted at, for instance, 10 seconds, right? And as the music plays, the SVG scrolls, and the nodes are highlighting, so you can think of it as a nice timeline that is scrolling as you play. And the architecture of this can be broken down into a few components, and as I already said, we've been already talking about 3 of them. But today we are going to focus on the playback service itself, not talking about animations, performance, and all that stuff. So first and foremost, in order to play the music, we need a media playback service, right? And a quick look at existing React Native APIs reveals there is nothing built in, right? However, that doesn't mean it's impossible. As I said, there is that escape hatch. And it just happens that both iOS and Android have great libraries built in by default. For the purpose of this talk, I decided to use Streaming Kit, which is iOS wrapper, just because it's more concise, it has smaller syntax, and it will be just easier to fit in slides. So once we know the libraries, let's go ahead and create native module that we will be putting those methods inside. And so I'm not going to go into the header file, which is .h, because that's where the definition is going to be. I'm going to be in the .m file, which is the place where I'll be implementing my methods. So what are the most common actions a typical media player should perform? It's most likely play, right? To play a song or resume it, to stop it, and to play next one, right? So 3 methods. Now, to be honest, there are way more things that we need to implement in order to make a production-ready player, like interruptions, such as when someone is calling you or you are listening to navigation directions, or background modes. In this talk, the focus is on the framework itself. If you are interested, feel free to ask me later about other methods or generally what is the approach to implement them. So now that we know them, let's go ahead and start writing some stuff. I jumped too much. Sorry, if you are having latest Mac, you probably know that it sometimes triggers double the key press. So when I press space, it skips many slides. Very handy. And so first thing is we have to export the module itself, right? So we got to put RCT export module. Nothing fancy. And then we're going to create an instance of the player that will live throughout the lifespan of this module. Now, this is not something that you usually do in your yet another native module, because this one is overriding the constructor. Basically, what I'm doing is I'm just setting a property audio player, because that's the most reasonable place where I can put it. And finally, we can directly expose play, stop, and next on the instance of the player. And as you can see, I'm wrapping every method with RCT export method, which will make it, again, available for the JavaScript to call. So this is very, very low-level deep stuff on the native side, which, as you can see, is going to be imperative, because we are basically calling play data source and stuff like that. So it's time to move one level up to the JavaScript interface. And we are going to create a very simple JavaScript wrapper with 3 methods to control the playback and all the other methods that we have created. And those APIs are async, and when called, we'll go over to the bridge to talk to the native code we just wrote, right? So to make it easier to visualize the React component we will be working on, let's pretend that this is the screen of the shiny new design that is going to be the new Spotify and Apple Music all together, right? And we would probably go ahead and scaffold something like this on screen that has the render method. It's not really important for case of this talk, so I'm just going to make it empty with three methods that basically going to call into the API that I just created, right? So at this point, we have already created our module that is imperatively calling some stuff, right? When I press stop, start, stop, it will be basically working fine. The problem is, as I started using this code in production, I started hitting typical imperative issues that normally we hit, like async mess, you know, like when I'm pressing stop, 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 resume many times, like I have no control over the bridge, how they're gonna be going, like some issues like that. And also, the bigger problem was from the long-term perspective that the responsibility to implement the player was on my team. Right? So when I made the library, or whoever made the library, I just made some building blocks to compose the player, but I didn't do the whole logic. So things like interruptions, background modes, were still left up to people that were just interested in doing the playback service, right? So you're shifting the responsibility on them, and they don't necessarily have to know how to write this. So for instance, the basic challenges are, as I said, interruptions, background mode, maybe you want to crossfade them, buffer up front, things like that. And answers to the above questions are not easy because it doesn't really fit into React model. Imperative code itself doesn't really work with React because React is declarative. And so I started digging around existing modules to understand how React Native team handled that before, which is actually an interesting takeaway. And every time you are wondering how to implement something, I encourage you to go to React Native source code, just look at something that they did, And it's a great resource of learnings and interesting performance optimizations that are not necessarily documented in the documentation. So on my way to answer those problems, I started digging around status bar API. Now, if you've been using React Native before, you know that status bar API used to be imperative. There used to be status bar.setStyle that changed to a component. So I thought, like, OK, if the team changed this API from imperative to declarative, there has to be a reason. The reason that is very important for my project as well. So just to recap, for those who haven't used old status bar API, this is how it used to be. You were basically calling set status bar style. You can technically still do it, but it's not a preferred way, let's say. But now it's a component that you can embed in your render hierarchy that will basically adjust your status bar style. So that transition got me thinking why it happened. Like, what was wrong with the existing approach? And so it turns out that one of the most annoying issues was glitches that were happening because of unpredicted calls. Because if you had many screens with those calls in component did mount, will update, and stuff like that, it was basically impossible for you to control how the status bar is going to look like. And it started reminding me the issues that I was running into with my player. So I thought it's going to be a good takeaway to dig into that deeper and rewrite the component itself a bit. And so I figured out that the source of all the issues and challenges, as I said, is the fact that I'm using imperative itself, which is 50% of the stuff. It's not like by making my library with that imperative interface, I only did half of it. The other thing that was missing was the declarative facade, like the declarative interface, the entry point, the public interface that will be for users, not for developers. So I started thinking in a declarative way, what would be the contract? What would be the props if my player was a component? So basically, I figured the most two important props from my perspective are going to be isPlaying and a song. So in order to get the music playing with the aforementioned API, all you would have to do is to place this component anywhere in your render method. And going to the next song is also easy. You don't have to think about anything. You just basically need to change the prop, and you are done. So now that we know how the declarative interface could potentially look like, let's take a look at how to actually connect these two together. So from here on, it's really easy. If we think of data source for this, what is the source of truth? Those are the props, right? And what is the place in the React lifecycle where we can listen for props changing? It's either a component will receive props or did update, right? In this case, I decided to use did update because I'll be calling breach. And so I don't want to call before the update just in case there's going to be a precious animation going on screen. And so this is a very, very dumb copy-pasted function from my production code that basically shows how I'm reacting to those prop changes imperatively under the hood. As you can see, it may look dumb. You may be laughing that this is very, very, stupid way of doing stuff, but it really works. And as you go deeper, as you start adding features like crossfade buffering and stuff, it's really performant, but doesn't look like this at the beginning, which is a real beauty. And so one bonus point is that the current infrastructure consists of a native module, a JS wrapper, and a React component. So 3 files to provide a very simple function. And that works for most of the time and most of the use cases that you might have. But you can also create a native view component where you can put all those things together. And so do you know what's the difference between a native view component and a native module? Who knows? Hands up. All right. So native module is like a library, right? It's like a piece of code that exposes some APIs from native to JS. So when you have a segment, for instance, Kit API, which is for tracking events, you can export those methods directly to JS through something that is called a native module. And for instance, an example of a native module from React Native Core would be alert iOS, yeah, that's a good example. And a native view component is something that you put into your render method as a JSX component, and that's native code as well. An example is status bar iOS, I'm not actually sure about, but map view, for instance, is a good example, or scroll view, or actually any other one as well. And so it is different from a native module that it defines this view method here. So in this case, I'm defining this view, and basically this is going to tell React that, OK, if this native module is rendered in React, please get an instance of view from this view method and put it inside render method. The rest of the properties stays the same. So we still have on progress, song, and playing props, so sort of direct corresponding prop. And then the implementation of this is really simple, or maybe not. Don't get scared with the square brackets of Objective-C. But as you can see, instead of component did update, I'm using this did set props method, which is exactly the same on iOS native side of things. It receives an object that basically tells me what props did change. So I'm changing the playback and a song based on the props that change. And now you may be asking, like, what's the point of doing native view component if it's like all that crappy Objective-C and it's hard to wrap our heads around it. As always, it's performance. So when you create a native module, the only way to pass an event is through an event emitter, right? So if you are creating a media player, scroll view, whatever, you're basically going to be emitting events through the bridge. As you emit those events through the bridge, you are going to cause some traffic over the bridge, right? And that combined with animations or all the other stuff you might be doing may cause your frames to drop. And so by defining an on-progress callback, by using component instead of a module, I have this precious ability to use animated.event. And when I use animated.event, what it will do is it will directly map this.state.progress, which is animated value, with whatever value will be from the on-progress event. Now, the beauty is that if you set the useNative driver to true, it will skip the bridge. So if you do 60 updates per second, which is what I was doing for the on-progress event, because the music was playing, right? You set this to true, and you can do whatever you want. Your app feels native, and there is no issue at all. So to sum up our work around the module, in order to make a performant library that plays music or does any other thing, you have to create a declarative interface that uses imperative core under the hood to get things done. And also the benefit of this is that you can make it cross-platform, right? Because on web, you can use video. In my case, in your case, that could be a different API to get things done. So does it mean that imperative is evil if we just created a declarative interface to it? It's not really, right? It's a foundation that React Native is built on top. And it's what makes all the things possible that we are using. Without the imperative code, it wouldn't be possible to do anything like show an alert, use clipboard on React Native, launch any other apps, and stuff like this. So I believe the API design like that, which is combining declarative with imperative, is the holy grail of React Native development. Because imperative code is powerful, but it can be used very badly. It can cause you a lot of troubles if you overuse it. And React and React Native are those guards that give you tools to handle the imperative code. So I encourage you to think of this pattern next time you are about to write an API. And who knows, maybe it will help you write a better app, something more maintainable, or basically more advanced. Thank you very much.